Hello everyone, welcome to ilustraca. So this is a new lecture series on fundamentals of matrix algebra, and this is the first lecture of this series where we'll be introducing you with matrix. First of all, what we need to understand is what is a matrix. So if I just write it here, what is a matrix? Okay, so if you want to say what is a matrix, so basically matrix is nothing but a bunch of elements, or you can say a bunch of numbers which are distributed or arranged in a particular number of rows and columns, right? Generally, suppose let us say A is a matrix, and when we say that A is a matrix, we I can say identify a matrix with this symbol which we call third bracket. So if we keep suppose A within this third bracket, so you can understand that this is a matrix. And what we do, this A matrix has bunch of elements or numbers which are suppose distributed in m number of, suppose you can say they're distributed in m number of rows, so m number of rows, okay, and those are distributed in n numbers of columns. Okay, when we say that you can say the elements are distributed in certain number of rows and columns, so let us say that we distributed those elements or numbers in m number of rows and n number of columns. So suppose we have bunch of elements which we distributed like this in rows. So suppose here 1 2 3 three number of rows, so where here m will be 3, okay, and we have distributed those you can say elements, suppose in uh, here 1 2 3 4 four number of columns, so here n equal to 4, right? So this A matrix consists of m number of you can say rows, n number of columns, and in this rows and columns we are putting some elements here, right? We are putting some elements or numbers here, correct? Like this, like this, correct? So what we can say that the A matrix, is having m number of rows and number of columns. We also define it, or we can say we also call it like m by n matrix. Okay, we also call it m by n matrix. So in this case, it will be 3 by 4 matrix. In this case, we call it as 3 by 4 matrix. And this 3 by 4 in this particular matrix, obviously it will be kept within third bracket. It will be kept within third bracket. So this 3 by 4 which we have written here, which is denoting the number of rows and columns of a particular matrix, we call this particular thing as the order of matrix. Order of matrix. Okay, so this m and n is denoting the order of matrix. So as an example, as we have three number of rows and four number of columns, so in this case it is 3 by 4 matrix, and the order of the matrix is 3 by 4. Okay, the order of the matrix is 3 by 4. Now what we said that we have a matrix, let us say matrix A, which is having bunch of elements distributed in suppose 3 number of rows and 4 number of columns. So these, each position of these elements, so if I just number it like this, okay, let me draw it here again. I'm trying to simplify the thing. Okay, it is very easy. We have studied it from the very initial stages of our schooling, right? So it is suppose 1 2 3 4, okay, it is 1 2 and 3, correct? 3 rows, 4 columns. So in this case, when we have one element here, suppose this element is, let me just write it here, suppose this element is element A. Okay, so how will be defining the position of this particular element? How will be defining the position of this particular element? So generally we define the position of this particular element in terms of I and J. Sorry, I have written J here first. It will be I and J. Okay, so I will tell you the row number, and J will tell you the column number. Okay, so when we say sorry, again I'm writing J first, it will be Aij. So it is telling us that A is situated in ith row. Okay, it is situated in ith row and jth column, correct? So now if I want to convert it, so what is this I don't know why I'm writing J first. Aij equal to this, fine. So when I'm writing in this particular format, so what I can write here, see, this is in the ith row, so the row number is 1, and this is in the jth column, so J here column number is 1. So this is A11, which is defining that the element A is situated in the first row and first column of the matrix. Okay, if I have the same element here, how will be defining the position of that particular element in the matrix? So it is in the first row and the second column. So I is equal to 1 here and J is equal to 2. Similarly, we can write it here, I is equal to 1 here, J is equal to 3. Similarly, I can write I is equal to you can say 1 here and J is equal to 4. Correct? J is equal to 4. Similarly, for the next position, okay, now if we have the A element, so how will be defining the position? Now it is in the second row, so I is equal to 2, J is equal to 1. I is equal to 2, J is equal to 2. I is equal to 2, J is equal to 3. Like that we can write it here, right? In the format of Aij. I is defining the row, J is defining the column. So again, now it is 3, I is 3, J is 1, I is 3, J is 2, I is 3, J is 3, and I is, you can say, what should I write it here? I is 3, J is 4. Correct? So this is a matrix having how many elements? So 12 elements, right? Within a matrix, within this third bracket, and we are defining the position of these elements in terms of I and J, where I is defining the row number of the element, row number, and J is defining the column number where the element is situated. Correct? So this way, so here, how many rows we have? We have how many rows? So you can say we have 3 number of rows. So here 3, and we have 4 number of columns, so 4. So that's why it is a 3 by 4 matrix. Okay, so this thing if we write for infinite numbers, like we do not know how many numbers we have, so you can say you can say 1 1, a 1 2, a 1 3, and suppose it is a, how much we can write? So it is suppose A1n, because here I know the m, you can say row is the first row, but I do not know how many you can say columns there will be, so I am writing as n. Correct? Similarly, I can write it here A21, A22, A23, and it will be A2n. Correct? Similarly, I can write it here A31, A32, A33, and here it will be A3n. correct? Now if I do not know how many number of rows are there, maybe there are bunch of many number of rows, so I can say, I can write it here that a m1, correct, a m2. Now the row is the unknown here, it will be m number of rows, so a m2, then a m3, and so ultimately we can go to a mn. This is basically telling us, this m into n is basically telling us that I would write it like this, a m n. So this is telling us how many number of elements are there, and what is the you can say uh, 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 order of the matrix. So this order of the matrix is m into n. So from here also you can see this a34, so you can see the order of the matrix is 3 by 4, and how many number of elements are there, 3 into 4, so 12 number of matrix are there, correct. Sorry, 12 number of elements are there. So this a matrix consists of m into n number of elements, and the order of the matrix is m by n, correct. Fine. So I hope you understood how we write a matrix. What is a matrix? It is nothing but a bunch of numbers or elements distributed in some particular number of rows, suppose m number of rows and n number of columns, okay, and within a third bracket. The m and n, which is defining the row, total number of row and total number of column, okay, it is nothing but the order of the matrix. Fine. Okay, so this is how like this is what matrix is. Now there is a term called diagonal elements. This is a term called diagonal elements. So what are the diagonal elements? So let me write it here. The first thing, we have diagonal element. One by one we'll be understanding. Okay, diagonal element. So which element will be called diagonal element? So here we have defined the elements, the position of the element in terms of I and j. Okay, so the elements where I is equal to j, I don't know why I'm writing j first, sorry, I is equal to j. Okay, so these elements together are called diagonal elements. Okay, these elements are together called diagonal elements. So this is the position of the element. Okay, element having position I equal to j. Okay, so these elements are called together, these elements are called diagonal elements. So here if you see here, if you just try to find out this a11, here I is equal to 1, j is equal to 1, so I equal to j. Here a22, so I equal to 2, j equal to 2, so I equal to j is satisfying, so this is one of the element. Here a33, okay, a equal to 3, j equal to 3, right? So if you have this kind of elements, so if you see this kind of elements are coming in a diagonal line, right, it is coming in a diagonal line. There may be some other elements also, so these elements are coming in a diagonal line. So these elements which are placed in a diagonal line, okay, where I equal to j, okay, if I equal to j, then only we'll get this diagonal line, otherwise will not, right? So these are called as diagonal elements. So we can say these are called as diagonal element. Okay, these are called as diagonal element. Here just a11, a22, a33 like this. Okay, and this line on which these diagonal elements are placed, okay, this line on which this diagonal elements are placed, this line is called, this line on which diagonal, obviously as the diagonal, I mean the elements are placed in a diagonal line, so this is a diagonal line. Basically I have not written here so this line on which diagonal elements are placed, so what we call this line, it can be multiple lines. So this line we call, this line is called as principal diagonal, Okay, diagonal or principal diagonal. So you can say this line is called as diagonal or principal diagonal. So both the thing is true. The elements which are on principal diagonal are diagonal elements, or you can say the line which are connecting, which is connecting the diagonal elements are actually the principal diagonal or diagonal simply. Correct? So these are the few terms that we'll be knowing. Already we know. I'm just discussing this. So just to refresh. Okay. So as we are just introducing you with the matrix, we already know these things, but we are just brushing up. Okay. So we know the order. Okay. We know how we distribute the elements in the in rows and columns. We know how to define the rows and columns in terms of I and j. We know what are the diagonal elements. We know what is the principal diagonal or diagonal. Okay, fine. Now let us say that there are different types of you can say matrices. Okay, so let us just know a few of this. Let us say types of matrices. Okay, types of matrices. So the first the very fundamental matrix that we have, let me change the color to something like this. Yeah, so the first one we have is the row matrix. Okay, so what is a row matrix? What is a row matrix? Can you tell me what is a row matrix? So row matrix where I is equal to 1, I is equal to 1, then we have j. Why I'm writing I and j? I'm not sure. Something has happened to me. Fine. So the position of the element will be like this, that this I will be always 1 and this j will be changing. So this is my, okay, this is my, so this is, let me write it, this is constant, and here this is variable. This is variable. So if we have a matrix with elements having position where I is constant, okay, j is changing, okay, in this case we will be calling it as a row matrix. How? That means there will be one single row and different columns. So let us say like this: a11, a12, a13, like that, a1 n. Fine. So this is a example of row matrix. So we can place it with 4, 5, 3, 8, like this. This is a row matrix because there is only a single row. So we can say single row is there, but there can be multiple, you can say. So if I just denote with denote with grid numbers, so that will be easy for you. So it is grid number 1, 2, 3, and it is grid number n. So you can see there is only one row, but there are multiple n number of columns, right? So this is the row matrix. Similarly, we have another type of matrix, which is let me write it like this. Yeah, so which is column matrix. Which is column matrix. Now, what is this column matrix? Just opposite to here, that. So here in this case, I is equal to variable. Okay, I will be varying, and j is constant. J is 1. Okay, so this is constant. It can be, it cannot be other constant actually. Okay, it cannot be other constant, it should be 1. Okay, so when I'm writing constant, it is not like 2, 3, 4, those are also constants, right? But here it is only one constant, which is 1. I mean, the constant is 1. Okay, so that means the matrix, if I write, it will be something like this. Sorry, if I write the matrix here, example of the matrix, it will be like this. A how we'll be writing? A11, A21, because we are writing the column here. A31, so dot dot dot, we can say AM1. Okay, so now if I just define it again with a grid, you can say this is grid number 1, which is defining the number of columns, and here I have multiple grids. Okay, so these are basically my rows. Fine. So 1, 2, 3, and 4. So same like when we place the columns, how we say that, suppose I have a column here. So I will be telling this column position. So suppose this is 1 and this is A. So I'd say this is column, you can say 1A. This is defining the position. Similarly here, A11 is defining the position of the element. So the matrix which is having only one column and multiple, you can say, rows, so this is nothing but a column matrix. Okay, this is nothing but a column matrix. Fine. Okay, now let us say there is another type which is called, you can say, square matrix. Square matrix. So from the name itself, you know what is this square matrix. What is this square matrix? So the, you can say, in square matrix, when we write the order m by n, okay, so here in square matrix m will be equal to n. In square matrix m will be equal to n. That means the number of rows and the number of columns will be same. So if I just write it here, it will be something like this. Suppose A11, A12, A21, A22. Okay, fine. So how many number of, from the last element you can see how many number of, you can say, rows are there? Two number of rows, right? Let me again write it here. 1, 2. How many number of columns are there? 1, 2. It can be, you can say, uh, m number of rows and n number of, you can say, columns, but this m and n shall be equal. So then we can call it as square matrix. Okay, we can call it as square matrix. So this is the example of a square matrix. I hope it is clear. Okay, I hope it is clear. So here m equal to 2 and here n equal to 2. So the order of the matrix is 2 by 2. So when m and n are equal, so you can say, we call this as square matrix. Similarly, now you know the next matrix will be rectangular matrix. So you can say the third one is rectangular matrix. Rectangular matrix. Okay, fine. So rectangular matrix, it is again, we know the order of the matrices will be m into n, but here m is not equal to n. Okay, m is not equal to n. Either m will be greater than n or n will be greater than m. Okay, so how we'll be defining it? So we can say suppose a11, a12, a13, right? a21, a22, a23. Fine. So what is the order of this matrix? 2 into 3, correct? So here m is equal to 2, n is equal to 3. So you can see m is not equal to, and this is satisfying. So this is a square, you can say, rectangular matrix. Similarly, we can write it like this: a11, a12, a21, a22, a31, a32. Okay, so here what is the value of m? So it is a 3 by 2 matrix, correct? 3 by 2 matrix. The number of rows are 3, number of columns are 2. So here m equal to 3, n equal to 2. So that means m is not equal to n. So that means it is a rectangular matrix, correct? It is a rectangular matrix. Fine. Okay. So next, I'm just giving you the types of matrices we have. Next we have, how many numbers we have written? 4. Okay. So the next we have fifth one, which is called null matrix. Which is called null matrix. Which is also called zero matrix. So null matrix. Okay. So what is this null matrix? This null matrix is that the number of elements number of elements. It can be square, it can be rectangle, doesn't matter. So we have a11, a12, a21, a22. Fine. So here this value of aij, ai, the value of aij, if I say, it will be 0, it will be 0 when I is equal to j, when I is equal to j, correct. Again it will be 0 when I not equal to, let me write this, not equal to j. Okay, so where I you can say equal to j, so here and here I equal to j, so this value is 0, this value is 0. And where I not equal to j, so here and here I not equal to j, so this value is also 0, this value is also 0. So if you write it in terms of like this, 0 0, so it can be a rectangular matrix, it can be a square matrix, doesn't matter. When I is equal to j or I equal not equal to j, each position the value of the element is 0, so we call this is a null matrix. So we can say this is the matrix A, which is a null matrix. Matrix A is equal to null matrix. That means the value of these elements will be 0 at any position, in the matrix. Correct? So we call it as null matrix or zero matrix. Fine. Okay. The next type, we will see one or two types, then we'll close this lecture, then we'll continue in the next lecture. Okay. So because we are just trying to understand the fundamentals first. Next matrix that we have, it is fifth. Okay. So the next matrix we have, the sixth one, this is called diagonal matrix. This is called diagonal matrix. Now what is this diagonal matrix? What is this diagonal matrix? Try to understand. We have matrix A, okay, which is consist of different elements, which is in terms of distributed in terms of aij, j. Okay, so a11, a12, okay, a21, a22. Let me write it one more, a13, a23, a31, a32, a33. Now what is this diagonal matrix? If we want to say diagonal matrix, so diagonal, the you can say properties of the diagonal matrix is that the value of aij, okay, ij is defining the position of a, so this value of aij, it will be you can say some you can say finite value, so it will be some finite value. Okay, it will be some finite value. When it will be finite value, when I is equal to j. Okay, so the position of the elements where I is equal to j, this will have some finite value, and the value of the element is 0 when I not equal to j. So every position where I not equal to j, the value of that element will be 0. So if I just place it like this, if you see here, I equal to j, so these are my I equal to j. If I just mark it as red, so these are my I equal to j, correct. So let me write the matrix. So matrix A, which is a diagonal matrix, how it will be? So I have A110, okay, A220, A330, because here I equal to j. So I can say, so here I equal to j. Now if I take another pen, suppose any green color pen, suppose, yeah, this one. So here the position locations, no, what I have done a mistake. I equal to j, there will be a finite value. So let me write some value, 2, 6, suppose 9. Okay, so these are finite values when I equal to j, and rest of the place where I not equal to j. So here if you see these values, These are not I not equal to j, correct? So these are my I not equal to j. Okay, so these values will be replaced with the, I mean, these positions will be replaced with the elements which is having value as 0. Okay, value as 0. So this is my so this is called as diagonal matrix. Diagonal matrix. Now just simply just to tell you that the diagonal elements, so these are my diagonal elements, right? So you can say diagonal elements will have finite value, and all other elements will be 0. Okay, all other elements will be 0. So in a matrix where only the diagonal elements are having some finite value and all other elements are having a value as 0, so these are called diagonal matrix. Okay, these are called diagonal matrix. I hope it is clear to all of you. I hope it is clear to all of you how like how we define a diagonal matrix. Okay, so for today's lecture I will keep it up to here only. We got to know how we write a matrix, what are the order of the matrix, okay, how we define the position of the elements in the matrix, okay, what are the diagonal element, what is the diagonal or principal diagonal. We got to know about 6 type of matrix today. One is row matrix, column matrix, square matrix, rectangular matrix, null matrix, and diagonal matrix. There are few other types of matrix we will be learning in our upcoming lectures. Okay, so I hope it is clear to you. So in this series we'll discuss such fundamentals about the matrix algebra. Okay, and we'll try to also see how to solve the solution techniques for a matrix. Okay, for matrices. So this is it for today. We'll see you in the next lecture. Thank you.